Academic 2.5 lecture, take 2, Friday, October 28th. Okay, so if I gave you, right, so we've been doing a lot of I'll write a polynomial down and I'll say, find the factors of that polynomial, right? I want to draw an analogy with something we're probably more familiar with, which is just regular numbers. So if I gave you the number 1,363, right, and I told you to find the factors of it, right? Could you do that? Could you do that? What? 3, yeah. So you're kind of just starting to guess, right? You probably just start guessing factors, right?
It's an odd number.
It's an odd number. It's not prime, though. It's not prime. You're going to start guessing numbers. Okay, that's kind of like what we've been doing with the possible rational roots theorem, right? Okay?
That's exactly. Just guess.
No, this is totally this is totally rogue for off the notes. I just thought this would be a good thought experiment. Okay, so and what if I told you that one of the factors of this number is 29? How would you find the other? How then could you would it be hard or easy to find the other factor?
Easy.
Be easy, right? What would you do? Divide, right? Divide by 29. You'll get 47, right? You get 47, okay? 47, okay? So you know 1,363 can be rewritten in the form 47 times 29, okay? Times 29. 2 prime factors, okay? There's a whole branch of mathematics where guys just try to find, or women and men try to find really big prime numbers and use it to encrypt your data, okay? Very, very applicable, okay? So that's kind of what we're doing with these polynomials, right? We're saying a polynomial, let's say f of x, right? Right. If I give you a factor, so let's look at 2.5, right? We're saying if I give you one of the zeros, so if I give you a 0 like x equals 2 or something, you know one of its factors is x minus 2, and to find the other factors, you just need to divide f of x by x minus 2, just like you would with this number here, okay? Do you see the analogy a little bit? Right? And then once we found all the factors, we know we can just write f of x as a product of all those factors, okay? So that's what we're going at. That's what we're going at here, okay? All right. So let's go ahead and take it away with, let's talk about 2.5 again. Let's keep talking about 2.5. Cool, right? So that's exactly what we're, whoa, sorry, yeah, I didn't screen mirror it. It's kind of hard for you to get anything out. Let me make sure I reposition the camera to look at the TV. Okay, cool. All right, so going back up to the top of 2.5, right? Right, so you're supposed to use this 0 to find the other zeros of this polynomial, or to find the other factors, okay? So since x equals 2 is a factor of f of x, we know that, or since x equals 2 is a 0 of f of x, what's the corresponding factor? I might just be asking the question. It'd be x minus 2. So we know that x minus 2 is a factor of f of x. Okay, are we following that? So then we just, to find the other ones, we do f of x divided by x minus 2, right? Right, we can do that with synthetic division, right? So to do that, let's do that over here. Do 1x cubed minus 6x squared plus 11x minus 6. Synthetic division, okay, we put negative 2 in the crow's nest. Okay, drop down this 1. Negative 2 times 1 is negative 2. Negative 6 plus negative 2 is negative 8. Negative 2 times negative 8 is positive 16. 11 plus 16 is 27. Negative 2 times 27 is negative 54. Negative 54, did I do something wrong? It'd be positive 2, you're right. Yeah, that's what I did wrong. Sorry about that. Sorry, that should be a positive 2. So 2 times 1 is 2, negative 6 plus 4, so 2 is negative 4. 2 times negative 4 is negative 8. 3 looking at this, right, this is my constant term. This is my x term. This is my x squared term, okay? So f of x divided by x minus 2 is the same as, is equal to x squared, right, minus 4x plus 3, okay? All right, so just like 1,363, we can rewrite, I'm going to erase this division here. Right, that means we can rewrite our polynomial as f of x equals x minus 2 times x squared minus 4x plus 3. Okay? Now, if we want to find the other two factors, we just need to factor this quadratic, right? So copy down that first factor. So this is x minus minus 3 and 1, okay? There you go. So we've got my polynomial factored all the way out, and then to find all the zeros, we just set each binomial, the binomials, each of these parentheses, equal to 0 to solve for x. So we know the zeros are 2, 3, and 1. All right. Cool. So we feel okay about that? Good. 2, 3, and 1. Okay. Part B, right? I started to fumble that one yesterday, and I realized right after class how you do this one. Right? So it's the same thing here, right? It's the same thing. Okay. So, right, because just like, right, when they told us x equals 2 was a factor, we did, when they told us x equals 2 was a 0, we knew that x minus 2 was a factor. If they tell us that 1 plus I is a 0, just like in the problem above, we know that x minus 1 plus I is going to be a factor, okay? So we can make this problem a lot easier if we do f of x divided by x minus 1 plus I, okay? Is that making any sense? Good? All right, so let's do that. And so we do that with synthetic division just like we do with real numbers. So I'm going to put 1 plus I in my crow's nest. Okay, I'm going to put the coefficients of my polynomial, 1, negative 2, negative 1, 6, and negative 6. All right. All right, write my little remainder box. Okay, drop down my 1. Okay, 1 times 1 plus I is 1 plus I. Okay, negative 2 plus 1 plus I, we just combine our like terms. So it becomes negative 1 plus I. Okay, then right here, right, I've got to write 1 plus I times negative 1 plus I. Okay, so let me do that multiplication on the board real quick. So 1 plus I times negative 1 plus I. Okay. All right. Boil this. So first, outer, inner, last. Okay. Okay. The plus I and the minus I cancel. Bring your negative 1 down. I plus I squared is what? What's I squared? Negative 1. I squared is negative 1. I squared is negative 1. That's like the heart and soul of complex numbers. I squared equals negative 1. So it's going to be plus I squared or plus negative 1 or just minus 1. Minus 1 minus 1 is negative 2. Negative 1 minus 1 is negative 2. So I'm going to have a negative 2 right here in my synthetic division. Okay, negative 1 plus negative 2 is negative 3. Okay. All right, 1 plus I times negative 3 is going to be negative 3 minus 3I. Right? Okay. 6 plus negative 3 minus 3I, so 6 plus negative 3 minus 3I. Right, I just combine my like terms here, so it becomes 3 minus 3I. This is 3 minus 3I. Or, just 3 times 1 minus I. Okay. If I factor out that 3, okay, and then I got to do 1 plus I times 3 times 1 minus I. That equals 3. I'm just going to rearrange my factors here. Okay. So let's FOIL. So first, this is going to be 3 times first outer minus I inner plus I last minus I squared. Okay. These cancel out. That minus I squared becomes a plus 1. Right? The minus I squared becomes minus negative 1. Minus negative 1 is just positive 1. This is 3 times 2, which is 6. That gives me 6 right here, and the remainder is 0, okay? All right. So that was a lot of work. So I'll move this down here for now. Okay, but we have f. I write out the result, right? This is going to be my constant. I write out my result just like I do when I divide by real numbers. Constant x term, x squared term, x cubed term, okay? So f of x divided by my factor here. I'll highlight it in teal. Right, this result was x cubed plus negative 1 plus I x squared minus 3x plus 3 times 1 minus I. Right. Okay. We still have a cubic there, right? Can we factor now? Can we factor now to find the rest of the zeros? We can't. We can't. So what we actually got to do is we got to repeat this process again. We've got to take our new polynomial here, right? We've got to divide it by another one of its zeros to give us something another thing even easier to work with. That maybe we could factor that. We confused by what I just said, right? We can't factor this, right? We made our life a little easier. We divided f of x by our first known factor. It gave us something a little easier to work with, right? Now we have a cubic polynomial instead of a quartic. We have a degree 3 instead of degree 4, right? We still can't factor though. Okay, we still can't factor. Okay, what we need to do is really just repeat this whole process that we just did. We need to find another root and divide our new polynomial by that new root to give us something that's even simpler to work with, that maybe we can factor. Okay, what is that? And I've told you guys this. I've mentioned it a couple times. I forgot yesterday, so I don't expect you to remember, but I did say it. What did we say when I think it's called the irrational roots theorem or the complex roots theorem, right? So if this is really important, if a polynomial has an irrational or a complex roots, what did we say? What's another root we know it has?
Isn't it like the opposite of it?
The conjugate. The conjugate is also. Then the conjugates. Then its conjugate is also a root. I forget the name of the theorem, but very important. Let's give that a box. All right. There you go. Okay, so we know one root is 1 plus I. What's another root? What's another root that this polynomial has? I'll write it in red right here. What's another root it has? What's the conjugate of 1 plus I? Do you guys remember how to do complex conjugates? You just flip the sign in front of I. So this would be 1 minus I. Okay? So we know another root is 1 minus I. Okay? Okay, so I'm going to erase my last long division. Okay? Now, I'll use red. Now now I'm going to do x cubed. I'm just going to copy it. Now what I can do is I can divide that result there by x minus 1 minus I, and that'll give me something even simpler. Okay, that's what we got to do here. Do you mind pulling your hood down? Thanks.
Yeah.
Thank you. All right, so let's do that. Some more synthetic division. So we've got a crow's nest here is going to be 1 minus I. Okay. Let's do it. They do it right over here. So crow's nest is going to be 1 minus I. Right. We'll have 1, coefficient of 1. We have a coefficient of negative 1 plus I, coefficient of negative 3, and a constant term of 3 times 1 minus I. Okay, little remainder box, okay? So it's synthetic division just like we've been doing, okay? So drop down to 1, okay? 1 minus I times 1 is 1 minus I, okay? Negative 1 plus I plus 1 minus I, that's 0, right? Isn't that 0? Okay. 1 minus I times 0 is 0. Negative 3 plus 0 is negative 3. 1 minus I times negative 3 is negative 3 times 1 minus I. And then these two cancel out, so it's 0. Okay. So this result here gives me x squared minus 3. X squared minus 3. Okay. So we got x squared minus 3. Okay. So we can rewrite this original polynomial f of x up here. We know we can rewrite it as f of x equals x minus 1 plus I times x minus 1 minus I. Okay. Times x squared minus 3. Okay. And then what's my last step? Now it's an algebra 1 problem. Can I factor? Let's highlight it. Oh, I hate that orange color. Let's highlight it in yellow here. Can I factor that with my algebra 1 rules? What does that factor to? X squared minus 3. All right, we got to know this. You guys remember difference of squares?
It's the dots.
Right.
Isn't it dots?
We make 2 pairs of parentheses. One gets a plus, one gets a minus. Square root of x squared is what? X. What's the square root of 3? Square root of 3. Yeah.
I'm at x plus root.
All right. So you guys still need a lot of practice before you can be successful in something like this on the test, right? But we've got to start. So our zeros, right? We just set each binomial equal to 0 and solve for x, okay? So the zeros, x equals 1 plus I, 1 minus I, negative root 3, and positive root 3, okay? Final answer. Final answer. Okay, is that a little better? Is that a little clearer than yesterday? Good, good. Right, so we watched Mr. Rushka do it. Now we just got to figure out how to do it on our own so we can do well in the test next week. All right. Do well on the test, get a good grade for quarter 2. It is, yeah, it takes work. Just do the test for you. Just teach you guys how to cheat.
Mr. Rush, did you ever cheat on a quiz in high school?
No, I didn't.
Never?
Like, did you ever cheat on like a homework?
Like copy someone's answers?
Yeah.
What about like, wait, what's the teacher?
Mr. Rushka was definitely the one sending them.
Oh, absolutely.
All right, C. Same deal here, guys. Same deal, okay?
Yeah.
So-
Did you cheat in sister's class?
Sister.
Sister?
Sister history. I didn't have her. All right, x equals 4i. So my 0 is x equals 4i. So what's a factor then? That tells me that what is a factor? Hey, Ben, you put the phone away, please. Thank you. That tells me what is a factor. X minus 4i, right? X minus 4i is a factor, right? Okay. So let's factor, right? Let's divide so let's do f of x divided by my factor to give us a simpler polynomial to work with. That's going to be, right, we put 4i up in the crow's nest here, write out my coefficients, 1, 0, 13, negative 48. Okay, drop down that 1. Okay, 4i times 1 is 4i, 0 plus 4i is 4i. 4i times 4i is negative 16. 13 plus negative 16 is negative 3. Did I do something wrong? That's going to give me negative 12i. There's a star next to it. What does the star mean?
That's what maybe it's impossible. Yeah, that's probably what it is. It's not possibly.
No, it is. Oh, you know what I forgot to do? I forgot to include the constant coefficient here. So there should be, sorry guys, get erasing. There should be a 0 here, I'm sorry. Right, because it's x to the 1x to the 4th plus 0x cubed plus 13x squared plus 0x minus 48. So there should be an extra 0. I'm sorry, guys. I forgot to add another 0, sorry. So now I can do it. 4i times 1 is 4i. 0 plus 4i is 4i. 4i times 4i is negative 16. 13 plus negative 16 is negative 3. 4i times negative 3 is negative 12i. 0 plus negative 12i is negative 12i. And 4i times negative 12i is positive 48. 0. Okay? Yeah, incredible. It's like that. It's the Eminem song where like the bridge is like insanely fast. It's like Rap God? Is it Rap God?
Yeah. Are you big into Eminem sandwich?
I wouldn't say it. I wouldn't say that.
What kind of music? Yeah.
All right, so we got
Definitely secretly
all right, x to the 4th. So this equals x to the 4th plus 4i x cubed. Guys, the test next week's going to be really hard, so I would try to minus 3x squared. Oh, it's cubed, right? My two. Sorry, keep making all these mistakes. So 3, 2, 1.
Please part of the project about
Sorry about that. Okay. So I'll get rid of my synthetic division here to save space. Okay. So then, right, we can't factor this. So what do we got to do then? What do we do? Right, Madeline, do you know? We take our polynomial here now. We do what? This new polynomial. I'll highlight it in green. What do we do with this now? What's that? What did we do in the last problem, guys? What did we just do, right? Once we got our that? Yeah, we got to do synthetic division again by what, Rylan?
4i.
What's the conjugate of positive 4i? Yeah, so we know if positive 4i is one of our zeros, negative 4i has to be another one. So now we can divide this. We can divide this by the other 0. Right, that gives us x plus. So it's going to be, so if our 0 is minus 4i, then our corresponding factor is x minus 4i, which is x plus 4i. Okay? So we're going to divide this by x plus 4i. Okay? Alright, so let's do that synthetic division. So put minus 4i in the crow's nest. Okay, and then 1 times 0 is 0. Negative 3 plus 0 is negative 3. Negative 4i plus times negative 3 is positive 12i. Add those up, we get 0. So this equals x squared minus 3 again, right? Which itself factors to x plus root 3 times x minus root 3 as we saw in the last problem.
And then all the zeros would just be like, would that just be like negative root 3, positive root 3?
Yeah, so I'm gonna highlight all my factors, right? Here's one factor, here's my other factor, and here are my other two factors. So our original function, f of x, can be written in the form x minus 4i times x plus 4i times x plus root 3 times x minus root 3. Okay? And then all my zeros, right, would be the opposites of these guys. So we get 4i minus 4i minus root 3 opposite. Okay? Alright, so it's a lot, but I think I'm doing it a little more justice today, okay? Alright. A little more justice today, okay? Alright, this next one here, 2a, right? I feel like you guys want me to redo this one too? Okay, yeah. Cool, right? So, write down all the zeros, right? So 2, positive I, what's my other zero going to be then?
Negative 5?
Negative I, yep, negative I. Yep. So I'm going to write f of x, my polynomial f of x equals, I'm going to put some just a here, arbitrary a here, and then x minus 2 times x minus I times x plus I, right? Okay. Okay, and then so I'm just about done. The only thing I'm missing is I need to make sure the point contains negative 1 comma 8. That's why I add this a in here. I have to make sure, right, on the homeworks that were similar to this problem, they just told you to write a polynomial with like these zeros, with zeros 2i and minus I. Right, so we could just set a equals to 1. We could just pick a and be done. Pick 1, right? Now they're giving us another step. They're saying, write a polynomial function with these 3 zeros and make sure it contains this point, right? So the way we do that is we put a little multiplier right here, a, right? And then to find it, we plug in 8 for f of x and keep a there, and then negative 1 for x. Right? Negative 1 for x. This becomes 8 equals a times negative 3 times, let's do the product of negative 1 plus I, negative 1 minus I. So negative 1 plus I and negative 1 minus I is first, outer, inner, last, minus I squared, okay? These two cancel, minus I squared is the same as plus 1, right? So that gives me 2. Gives me 2. Right? So a equals minus 6a, or a equals negative 4 thirds. Good? Okay. Okay. So for my final answer, I just plug in negative 4 thirds. You guys feel okay about that one? Good, good. All right, let's skip B then. So I just want to say though, what would our third zero here be? I think we're having trouble. Kayla, what would my third? So my 0 is 1. Another 0 is 1 plus 2y. What would my third 0 be? Good job. Okay, I just want to make sure we understand that, right? Good. So, good. Good. Yeah. So then we do f of x equals some arbitrary, not arbitrary, but some a times x minus 1 That's x minus 1 plus 2i. That's x minus 1 minus 2i. Okay. Contains, did it cut off? Oh, negative 1, 4. Right, so we plug in 4 here, and then a negative 1 for x. Right, and then we solve for a. Right, in the interest of time, I'm going to go ahead and move on to the next part so we can get all this in before the weekend. Okay. Anything we don't finish. Okay. So these three, right? These three right here, okay? These three problems. Find all zeros. Find all zeros, okay? So what do you guys want to try? What do we always try first?
Factor.
Can we factor? No, so what do we do when that fails?
PFF.
PRR. That's we put all the factors of 5, so plus or minus 1, plus or minus 5. We put them all over the factors of the lead coefficient, plus or minus 1. Let me do some highlighting here. So factors of the constant term over factors of the lead coefficients. Okay. So our possible zeros are plus or minus 1 and plus or minus 5. Okay. All right. So let's try 1. So f of 1, we're just guessing and checking. F of 1 equals 1 cubed plus 4 times 1 minus 5, which equals 1 plus 4 minus 5, which equals 5 minus 5, which equals 0. Okay. So one of my roots, right? We have the root x equals 1 here. X equals 1. Okay, so that means a factor of my f of x here. Okay, a factor of f of x. If one of my zeros is x equals 1, then one of my factors is x minus 1. So let's do f of x over x minus 1 and see if that gives me something that's easier to work with. Okay, so let's do some synthetic division. Alright, so we'll do crow's nest has 1 in it. 1, 0, 4, negative 5. I always just try to rush through these. Gets me into trouble. 1x cubed plus 0x squared plus 4x minus 5. So 1 and 9. So this is 1. 1. 1. 1 times 1 is 1. 4 times plus 1 is 5. 1 times 1 is 5. So then we get x squared plus x plus 5. Okay. What's that? Is that factorable, the quadratic? What do you mean, like, I'm sorry, did I misinterpret your question? So we know one of the roots is 1, and then we can just have to factor that quadratic to the others. Or, can you factor it? I don't think you can. So what we're going to have to do is we're going to have to use the quadratic formula, okay? So, right, a equals 1, right? That's the coefficient of the x squared term. B here, b is 1. B is 1, that's the coefficient of the x term. And then my constant term is positive 5. Okay? So the other two zeros are going to be x equals, the opposite of b, negative 1 plus or minus the square root of b squared, so 1 squared minus 4 times 1 times 5 all over 2 times 1. Okay? That's negative 1 plus or minus, what is that, 1 minus 20. So negative 19, the square root of negative 19, all over 2, which is negative 1/2 plus or minus I root 19. Yeah, similar. Yeah. So my zeros are x equals 1, x equals negative 1/2 plus I root 19, and x equals negative 1/2 minus I root 19. Okay? on to, usually the last one's the hardest, so let's do the hardest one together. I think we're only going to have time for one more. Okay. F of x equals this polynomial here, okay? Can we factor it? No, so what are we going to do? PRR, okay? So plus or minus 6, or no, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. So we have 4 possible, or 8, I guess, possible rational roots here that we got to try plugging in. Okay? All right. Let's get a good guess going. Let's guess -1. So if we do f of -1, that'll give us -1 to the 4th is 1, minus 1, plus 5, plus 1, minus 6. Okay. These will cancel, those will cancel, so that equals 0. So one of my roots is x equals -1. We'll keep a list going up there. So then I have to divide, right? Then I have to, so x equals -1, that gives me a factor of x plus 1. So I'm going to do f of x over x plus 1. Okay. So to do that, I got to do my synthetic division. So 1, 1, 5, -1, -6. Put -1 in my crow's nest. Okay. Okay. So that equals x cubed plus 5x minus 6. All right. And then I think I have to guess again, right? So let's repeat the PRR. We have to repeat PRR again so that my possible rational roots are going to actually end up being the same list here. So you would repeat PRR again. You get plus or minus the factors of this 6 over plus or minus the factors of this 1. Gives you these 8 possibilities. Let's try +1. Okay. So if we do +1, that gives us 1 cubed plus 5 minus 6. So +1 is going to be another root. Okay, so we're going to divide this by +1. Okay. So that'll be that gives us a factor of x minus 1. So do you guys see the process, though, that we're repeating? So 2.5 homework for Monday, or Tuesday, please. I don't think I see you Monday. 2.5 homework for Tuesday. So we didn't get through everything, but we see the general process. Yeah, so your tools, right? Use the box here. Use the box. Use your possible rational roots. Just keep dividing, keep dividing, keep dividing.
That was ours. That was mine. Alberto's.